we were dealing with exponential equations and solving those exponential equations. This is a version of an exponential equation. We call this an exponential equation in quadratic type, meaning it looks like a quadratic, doesn't it? Okay, it has that behavior where we've got like an ax squared plus bx to the first plus c equals 0, where 1 and 2, these exponents, are half of one another, right? Would you agree that exponent and that exponent are half of one another? All right, so that's quadratic type. If you remember, we did these with things like, if I said I have like x squared, or let's say x to the 6th minus x to the 3rd minus 6, then we let u equal x cubed, then u squared was x cubed squared, which was x to the 6th. We've done this, right? This is the same exact thing, but instead of letting u equal x cubed, we're going to let u equal e to the x. Does that make sense? Okay. Now you always let it be just this exponential expression. You do not include any coefficients. Okay. So in the next one, I think we're going to see a 4 there. So I would not include that 4 there when I'm defining what u is. I would just let e to 2x be my u. Does that make sense? Okay. All right. So here, like I said, we're going to let e to the x be u. So u is e to the x. Now, what I'm about to do, I'll do this in blue. I'm just checking to make sure that I've made the appropriate definition for u. Okay. So I'm going to write this because we need u and we need u squared, right? So I'm going to write u squared, and I'm going to try to figure out what u squared is going to look like. My hopes is that u squared eventually looks like that, and then I know that I've got the right u. So I'm going to write u squared. Well, that turns into be, well, if u was e to the x, u squared would look like that, right? Well, what do I do with the power to a power? Multiply them. So does u squared yield my first term e to the 2x? Yeah, so I know that this red statement here, this definition of u, is appropriate. Now I just do my substitution. So I'm going to have u squared minus u minus 6 is equal to 0. Can we factor that? U minus 3, u plus 2 is equal to 0. So u is 3, and u is negative 2, right? Once we get this definition of variables set up, all of this is algebra 1, okay? Now once we solve for u, remember though, we want to solve for x, right? So we're going to back substitute, okay? Remember u was e to the x. So e to the x is equal to 3, and e to the x is equal to negative 2. So now hopefully you see the reason why these types of questions are in this section, because now when I do that back substitution, is that an exponential equation? Yeah. Okay. And what's nice is that doing this process, I've isolated the exponential part. I can now take the natural log of both sides, right? I'll take the natural log over here, and then I'll take the natural log of that 3. Okay. What is the ln of e to the x? What did we talk about yesterday that always provides you? It just gives you x. And then, obviously, I'd be left with ln of 3. So that solved then for x. Just kind of a side note, doing that ln of e to the x, just remembering what we talked about yesterday with it. Ln of e to the x, there's a couple different ways you can view this. You can go off of the law of logarithms, that last law of logarithms, which means you take the exponent out front and rewrite it that way, right? And then make the substitution that ln of e is just 1, right? Okay. Because remember, ln of e is actually log base e of e, right? Well, what do I raise e to come back and give me this e here? It's got to be 1. Okay. So that's one way of approaching it. Another way of thinking about it, which I'm going to make the argument it's really the same thing, is using the rule that said, if I have ln of e to the x, then that can be rewritten as log base e of e to the x. And then I ask myself, well, what do I have to raise that base of e to? So I come back and get the argument e to the x. Well, it has to be x then, right? And the answer to that then is x, so it gives me this here. I think yesterday maybe I told you guys this. I maybe showed you something where whenever you have ln of e to maybe some function, okay, or just some expression, you're always going to be left then with that expression. Okay, so if this was like ln of e raised to the x plus 2, then you'd be left with just x plus 2. If I was left with ln of e to the x squared plus 3x plus 5, then I'd be left with just x squared plus 3x plus 5, right? When you have ln of e, you're always left then with whatever that exponent is of e. That's something that's the main benefit of when I saw e here, I used ln. Okay, you can do it with any logarithm you want to. You want to use log base 10, by all means, go ahead and do it. It's just not as convenient. Okay, the one on the right, okay, so if I take ln of this one, it's going to give me x again, right? But ln on the right-hand side is ln of negative 2. What's problematic about that? Can't take the natural log of a negative number, right? It's not in the domain. Negative numbers are not in the domain of a logarithm. So ln of 3 is my only solution. Okay. Now, if I want to check that, I'm going to go to my calculator, and I'm actually going to change my calculator real quick. Let's get me the better one. All right, so I'm going to go, I'm going to type in ln of 3, maybe. What's going on here? All right. Type in ln of 3. And I'm going to hit STO, store, as x, hit enter. And now I'm just going to type in e to 2x. Was it minus e to the x? I don't like this math print thing. I always, when it takes me up to that exponent, I'm just in the habit of hitting my exponent and then minus 6, and it puts that minus 6 up there in the exponent with me. To get out of that, so when you're stuck up there, to get out of that exponent, that's what it's giving you that arrow. It tells you click over on your directional pad, and it'll get out of there. That should give me 0 back, and it does. Okay. So in the last class, and I've been using this calculator for since I was your age. There is so you got second ln, and it gives you that automatically, right? Okay, or it'll put, if you got the other version, I'll put the caret there. If you go second division, it gives you e just to the first. Okay, so if you want to use that, if you're a person that doesn't like always having to put that power of 1 in there because of e, you can go second division. It'll put that in there for you. I don't know why the need for 2 functions that do the same thing, but that is there for you. All right, so let's do another one. Hopefully you realize, obviously, again, if you wanted to check like ln of negative 2, if I go ln of negative 2, your calculator is going to tell you there is a problem with that. It's a non-real answer. It does not exist. Okay? So looking at this one, okay, again, like I said, this one's a little bit different because obviously it's not 2x and 1x, it's 4x and 2x, but they're still double each other, right? And The last one had a coefficient out here of 1. This one's got a coefficient of 4. That coefficient doesn't matter to our substitution. We're always going to pick off that part right there, and we're going to let that be our u. Okay. So then when I write u squared, okay, well, u we said was e to 2x, and then square that. Okay, so that squared and that squared are the same object. Okay, and then u was e to 2x. So we got a power to a power, so what's that give me? E to the 4x. Is that exactly what we wanted right there? Yeah. Okay. Now, as you're doing these, guys, there's nothing wrong with maybe at some point having some other coefficient out here. Okay. So chances are then you'd probably use the AC method, right? That will all be something that maybe is addressed in homework or something like that. But that is an option. Okay. You could have a coefficient out there other than 1. So now we're going to go u squared plus then 4u minus 21 equals 0. What's that? U plus 7, u minus 3. So u is equal to negative 7, u is equal to 3. But u was e to 2x. All right, so once I get those exponential equations, I then take what of both sides? Take natural log, right? We go ln of that side, ln of that side, so it gives me, what's this side going to give me? 2x. And the right-hand side is ln of negative 7. Hopefully at that point you stop, or at least with that equation, because can I take, even though it's only 2x, can I take ln of negative 7? No. So there's no way I can take half of that, right? So that doesn't work. Over here, though, take ln of both sides over here. So I'll have 2x is equal to ln of 3. X then is ln of 3 over 2. And that's going to be the only solution that when plugged in there, I get 0 back. I would not, because there may be situations where, if I'm going to take the natural log of that negative number, then yeah, you just cancel out. But I would be cautious that when I get like e to the 2x, when I get some equation to be negative there, like that, I would go one more step, just to make sure that there's nothing here that would undo that negative. When we took the natural log, now the reason I take natural log is because ln and e work well together. Let's look at what would happen if I would have taken like e to the 2x, if that is equal to 3. I'll take the log, let's just do log base 10 of both sides. See what would happen. Okay, so log base 10 of e to 2x is equal to log base 10 of 3. You see how, now I could do this, I could take the 2x out in front, right? I go 2x log base 10 of e is equal to log base 10 of 3, right? Can I isolate this x over here now? Because remember this, whenever I see the word log 10, log base 10, log base of anything, that's a number, right? And I can double that number, so that's just a coefficient. So would you guys agree I could divide both sides by 2 log 10 of e? So give me log base 10, come on, log base 10 of 3 divided by 2 log base 10 of e. That looks different than this, doesn't it? Okay. But if you were to evaluate both those on your calculator, I'm going to save a little bit of time doing this, they're both going to equate to the same thing. Okay. Now, here's the reason why. You guys remember yesterday, and we didn't spend a whole lot of time on this yesterday. I think we just used it one time and just kind of in passing, but you also talked about this quite a bit maybe last year. If I have log base b of x, and I want to change that base, I rewrite that as log base whatever I want to choose, so I just write a here, of then x divided by log base a of b. Okay, and a, like I said, that's what you choose. Okay, and then x should be, x is always the argument of the left-hand side, and b is always the base of the left-hand side. Well, look at this. Look at log base 10 of 3 over log base 10 of e, because that's what I've got over here, right? Now, I know I got a 2 out there, but that can be written, can be brought out as a 1/2. So let's look at how we could change this. So this here is exactly the same thing as that, right? Okay. So the a does not show up on this side, but I just got to make sure it's the same. So it is base 10 on both sides, or numerator and denominator. So now my argument is that number right there, which is that number. So there's my argument. And my base right there, which is going to be right here, is that object in the bottom, right? So if I put e there, is log base e of 3, is that ln of 3? And is that what we have right there? And if I multiply by that 1/2 out in front, does that give me exactly this? So it's kind of a little bit of a proof to show that that thing there, using the change of base formula, does turn into that, or this thing using the change of base formula does turn into that. So my point is, use whatever logarithm you want to, okay? However, if your base and your exponential is 10, use the common log. If your base and your exponential is e, use the natural log. Is that all right? It may be beneficial if my base is 4 to use log base 4. Does that make sense? Okay. But a lot of times, the just general fact, the easiest thing is just to use ln. But the change of base formula allows us to see that that is why we can just use ln all the time if we want to. Okay. Can we do those types of questions? They're all the same. Okay. Pick off what you want u to be. You then find u squared and substitute factor. Use your logarithm then to bring that exponent out. All right, so let's talk a little bit more about these logarithmic equations. Okay, you're going to have this slide here is explaining one version of a logarithmic equation that you're going to see, and it's the one-to-one relationship. It's saying that if you have log base 4 of, I'm just going to write f of x here. Now, it doesn't necessarily maybe have to be a function, but just f of x. And, come on, tablet died, there we go. On the right-hand side, I have log base 4 of g of x, okay? In order for the left-hand side to be the same as the right-hand side, what this is saying is that whatever that is has to be equal to whatever that is. Does that make sense to everybody? Okay, whatever that expression is has to be the same as that expression for the left-hand side to be equal to the right-hand side. Now, that might be, it might just be x and 3. So x equals 3, right? But this might be a quadratic. It might be a cubic. It might be whatever. Okay, it might be a rational function. Okay? But it might be a square root, whatever. But that thing there has to be equal to that thing there if we have log of the same base on both sides. Is that okay? Now, let's say I had something like this. Let's say I had log, I don't care what base b of, let's say, f of x plus then log base b of g of x is equal to log base b of h of x. Do you see that we have a problem here now? We do not have a one-to-one relationship because we have log being written multiple times over here. But what did we talk about a couple days ago? If I have two logs being added together that have the same base, can I rewrite that? Can I rewrite that as log base b of f of x times g of x is equal now to log base b of h of x? Does that make sense? So now do I have this one-to-one relationship? And now in order for that to be true, and in order to solve that, now all I have to do is take that thing there equal to whatever that thing is. Solve whatever that remaining equation would look like. Might be quadratic, might be cubic, might be a root equation, might be a rational equation. I just don't know. Okay? Depends on what f and g and h are. Okay? So that's one type of equation that you're going to see that is logarithmic. The other type is just going to be when you have log some base of some argument is equal to something else. I just say g. Okay? Well, I don't have log on both sides here, right? So I can't use the one-to-one relationship. But I can use the definition of a logarithm. Can I say b to the g is going to come back and give me f of x? And what's going to happen most of the time, guys, is that this f of x is that's the expression that it contains your variable. B and g are probably going to be real numbers. All right, so that will give you then an equation that you can solve for x. All right, so those are your two options with logarithms, and we're going to see a handful of those variations here. Now, the math that goes along with these might address all your factoring techniques. It might address the quadratic formula. So you want here to address the quadratic formula. Like I said, you can get your rational functions and all that kind of stuff. So you just got to be cognizant of once I apply these properties, what remaining equations are left, and then how do I deal with those remaining equations. So this is one-to-one. Okay, that is the same base as that. We see log written on each side one time. So in order for this to be true, we just have 4x is equal to x squared, right? Okay, did we do this one yesterday in class? Can't remember if I did this. I know I did it with first period. I'm not sure if I did it with you guys. All right, so I just get 4x equals x squared. So now we have to realize what that means. That is an equation that has an x squared in it, right? So when you have an equation with x squared in it, what do you always want to do? You could, but if I can't take the square root because that's going to leave me with x here. So I'm going to have a variable result if I do that. Okay, so I have factor, and I want to get something like that, right? I want to be able to see what my GCF is here. Now, if this was just a 4, absolutely use the square root method. But if it's a variable term, you're going to have to do this. You're going to have to factor this way. So now bring out an x, and I get that. So now that solves x equals 0 and x equals 4. With logarithmic equations, okay, our arguments have to be greater than 0, right? And you got two approaches to this. You can just say I'm looking for, that 4x has to be greater than 0, and x squared has to be greater than 0. Okay, meaning then obviously x has to be greater than 0, right? These two things need to both be satisfied, so we need and. So we're looking for solutions that, that says x has got to be greater than 0. We're looking for solutions that say x is greater than 0 and x is greater than 0. Well, that overlap is just x is greater than 0, right? So using that logic, which one of these works? 4 is the only one that works, right? If you want to use that idea of looking at your domain, it's similar to what we did with square roots. When we look at the square root, we just said that the radicand had to be greater than or equal to 0, right? And then we knew kind of what our solution should look like at the end. With logarithms, we just said that argument has to be greater than 0. The other option is to just do the direct substitution. When I get two answers, just directly substitute that in. Okay. If I go and put a 4 there, I get 16, right? Can I take the logarithm of 16? Is that a valid number for logarithms? Is it positive? Yeah. If I put 4 in there, I get 16 again, right? Okay, I can take logarithm of 16. So 4 is an answer. But when I put 0 in there, I get 0 back, right? Can I take the logarithm of 0? No. Okay, so that's the reason that goes away, and that would be analogous then to the idea of why we had to say x had to be greater than 0 at the beginning. Is that okay? All right. I'm going to skip the next slide because it just gives you a guidelines for setting up these equations, and my hopes are through seeing enough examples we can recognize that guideline. Okay. If you need that, obviously go back to the PowerPoint and address it. The number one thing I think about when doing equations is I never like to see ln. I do not like to deal with ln because it's obviously ln is the purpose of it is to be more concise with my writing, and it distinguishes it from just a different logarithm. Another logarithm makes it maybe writing it with a different notation like this instead of writing the base in there says it's a little bit more special than any other logarithm. But doing that loses, I think, a little bit of understanding about what we're trying to do here. Okay, I think it becomes a little bit vague. So I always take natural log when I'm doing a logarithmic equation, and I always rewrite it this way. ln is just that thing right there, right? So I have ln of x. Okay, so ln of x just looks like log base e of x, and that is equal to 8. This is one of those equations where you do not have logarithms on both sides, right? So if you do not have logarithms on both sides, you have to use the definitional logarithm to help you solve. So you take your base, e, you raise it to your exponent, 8, and that should come back and give you your argument. And every time that we do one of these, you're going to see that your argument is indeed the part that has your variable in it. So that gives me an equation. So this base raised to 8, that's just a number, right? Equal to x. That's my solution for this one. Okay. You can plug in your calculator, or you can use this fact. If I go ln of e to the 8th, okay. If I want to rewrite that, can I take that 8 out front? And write ln of e. What's ln of e the same as? Just 1, isn't it? Don't I have 8 times 1 there? Okay. Or if we want to go back to what we said at the beginning of class, we have ln of e to whatever expression, that equates to whatever that expression is. Okay. So hopefully that makes sense on what x has to be in regards to kind of checking that value of e to the 8th. The bottom one, again, I don't have a one-to-one relationship, so I got to use the definitional logarithm. So I take that 2, and what am I going to raise that to? I'm going to raise it to the exponent of 3, and it should come back and give me 25 minus x. Is that an equation you can solve? What's 2 cubed? 8. So subtract 25 gives me negative 17, so negative 17 equals negative x. So then x is 17. The only thing I would be cautious of, the 17, when I plug it back in here, the 17 is a positive number. It does. And does it make sense that log base 2, when I plug 17 in, it gives me 8? Does that satisfy this equation? Does 2 to the 3rd come back and give me 8? Okay? So those are your kind of most general, basic logarithmic equations. And the resulting equation from using our definition was linear there. But it doesn't have to be. Okay? It can be quadratic. And quadratic is kind of the type that authors like to use the most. They like this thing here to end up being quadratic. So when I use my definition of a logarithm, I get a quadratic equation. I solve it because that then reiterates what we've been working on for the rest of the beginning of the year. Allows us to practice that work again. But again, like I said, this could be rational. It could be a square root. It could be whatever. But I take my definition of logarithm. 2 to the second power should come back and give me x squared minus x minus 2. You see that power of 2 right there, and instantly you should think factor. And when I think factor, I should get everything equal to what? 0. So I make this 2 squared 0 by subtracting it from both sides, right? So you guys agree? Give me x squared minus x minus 6. Can I factor that? X minus 3, x plus 2. So x is 3 or x is equal to negative 2, right? Just be very, very, very cognizant of the fact that when we get multiple answers, sometimes some of those answers are extraneous. They do not work, okay? So you just got to check. I got to make sure that when I plug back in here, I just get a positive number, right? So I plug 3 back in. I get 9 minus 3, 6 minus 2 is 4, right? Can I take square, or can I take the logarithm of 4? Yeah. And think about, does that make sense? Does log base 2 of 4 equal 2? Yeah. 2 squared should come back and give me 4. So it works, so 3 works. Now I just got to check negative 2. Well, negative 2 squared is 4 minus negative 2 would be 6 now, right? And then minus 2, does that give me 4 again? So they both work. Okay. Let's do one more. Do you see log on both sides? Careful now. It's only on one side, right? But you see it twice. That's a problem, okay? We need to condense that. We need to go back to the property that said log base m of A plus log base m of B is the same thing as log base m of AB. Okay? So when we have addition, we need to multiply, right? So I'm going to rewrite this as log base 9 of x minus 5 times x plus 3 is equal to 1. Now, if you want to multiply that out, there's several different places or kind of steps within this problem that you can address multiplying that out. Maybe I just do it now. I'll go x squared. So it's going to be minus 2x minus 15. Okay, so I have to, and you're always going to do this when this is a expression here and this is an expression, you have to FOIL this. Okay, now it might be a trinomial and a binomial, it might be a monomial and a trinomial, whatever. So that word FOIL is kind of maybe erroneous sometimes, but you're going to do that distributed property. Okay. So now once I have log written on one side, right? And it's only one time. So now I can use my definition. I can say 9 raised to the first is equal to x squared minus 2x minus 15. And I always think with these problems, people struggle with these, is when we do this, we FOIL that out, and then almost instantaneously we have to start factoring again, and we think, well, we're undoing what we just did. Well, we're not, because I can only factor when one side is 0, right? So I want to take that 9 away, and now I'm going to factor that, which that is different. It will not factor as x minus 5 and x plus 3, right? Okay, because that constant is a different value. So now I factor that, I'm left with what, x minus 6, x plus 4. So x is equal to positive 6, and x is equal to negative 4, right? I'm going to address this two ways. So if I look at that thing right there, x minus 5 had to be bigger than 0, right? So does that mean x has to be bigger than 5? Okay. This says x plus 3 has to be bigger than 0. So x has to be bigger than -3, right? But this is because they're all in one equation, I need this to be an intersection. I need this to be and. Okay? Because this needs to be a positive number, and this needs to be a positive number to evaluate, right? To add those together, they both need to exist. Okay? So I need and so that if I were to graph what this is going to look like, -3 is there, 5 is there, that would be greater than -3, that would be greater than 5. The and would be this stuff over here, right? So greater than 5 is actually the restriction that I'm looking for that's going to tell me what my answers are. Okay, I can only choose x values that were greater than 5. Well, out of my answers, which ones were those? Just 6. Okay, so that's the way I do it. I'm not saying that's the only way. That's absolutely not the only way. I think that's actually the harder way. Okay, it uses more kind of appropriate math, I think, or more algebraic skill, I guess. But if you get two answers and you want to see, does this one work and that one work, plug them in. What's 6 minus 5? 1. Can I take the logarithm of 1? Yeah, it's positive. 6 plus 3, what's that? 9. Can I take that logarithm? Absolutely. So 6 works. Plug in -4. What do I get here? -9. Can I take the logarithm of -9? No. So does it even matter? Does it even matter that this one gives me -1? No. What if this one gave me a positive number? Would it matter? No. Okay. If this one gave me a positive number, do I still have to check this one? Yes. Okay. So make sure that when you do plug in your solutions, that you're plugging in and checking every single logarithm that variable is part of to make sure that you don't get a logarithm of 0 or negative. Is that okay? We can see here. I'll come back maybe if we have time. I explained something in the last class that obviously we can use our calculator to check these things, right? Okay, some of your calculators are deficient in their syntax. Some of them don't have all the functions that your other calculators have. And I just want to talk about how maybe we can address that situation if we have a kind of an outdated calculator. This one, I want to make sure we get through this one. Can I rewrite this as ln of, now this is a sum, so I turn that into multiplication, right? And guys, this would happen, I don't think I have any examples here, but maybe you have ln 2 times on this side and you have ln 2 times on this side, right? You're going to have to condense both sides. Does that make sense? Okay, so if you've got sums or differences, you're always going to condense them wherever they're at. So if I condense that, it turns into multiplication. So I'm just going to do that multiplication. It gives me x squared, plus x minus 2 is equal to 1. X squared plus x minus 2 equals 1. Now, I don't like using natural log. Whenever I see ln in these equations, I'm going to write it this way. So think the ln creates vagueness. We lose an understanding of what we're supposed to do. If I write it as log base e, now I see my base that I'm supposed to raise my exponent to come back and give me my argument, right? Obviously, that's not as evident when I write it here. I don't see my base there, right? It's not visible. So that's fine. That's quadratic now, right? All right, so get everything equal to 0. And I think my hopes are that we realize that this is a problem in regards to maybe our factoring techniques, because -2 minus e, that's my c term, right? And what kind of number is e? Irrational. So if I subtract 2 from that, or -2 minus e, that's irrational as well, right? Okay. What's a rational number times a rational number? A rational number. It's called a closed field. Okay. You'll talk about that maybe if you get into higher level math in college. But a rational times a rational always gives me a rational. So is my AC technique going to work here, or my product times sum technique going to work here? No, because we're always looking for rational numbers in those things, right? And there's no way I can take two rational numbers and multiply them together to get an irrational. So that's a problem, okay? And I'm actually going to rewrite this because I struggle with the substitution that we're going to use here in a minute if I don't write it this way. Do you guys agree that's the same thing? What will always 100% of the time work for us when we factor? Say again? Quadratic formula, good. And what we see here is obviously our b is 1, so -1, plus or minus b squared minus 4, a is 1, c, -2 minus e. Okay? If I don't write it this way as plus the opposite, 2 minus e, or plus that expression, I always put in the wrong signs for my c for some reason. So I always group that c term and make this sign here positive. Okay? And then, obviously, over 2. Now, again, you're not going to simplify that without a calculator. So let's work through. I'll kind of show you maybe the most efficient way of doing this with your calculator. I'm going to put a parenthesis, -1 plus second square root of 1 minus 4, and I don't need the other 1 there, but I do need the -2 minus e, right? Okay, so that is my numerator. I'll divide that by 2. Okay, hit enter. Okay, give me 1.7. So what I'm going to do is I'm just going to check this to see if it works. I'm going to store that as x, and I'm going to type in then ln of x minus 1 plus ln of x plus 2. Gives me 1 back, right? Is that what I wanted? So that works. Now I got to check the other one. So I'm going to hit second enter, second enter, second enter. It's going to go all the way back to this quadratic formula expression, and that plus sign now becomes a minus, right? I don't want to type all that stuff back in. Hit enter, gives me that number. Now you can do one of two things. You can blindly say, I'm going to go and evaluate now and store that as x, and then go recall the ln of x minus 1, or you can realize, well, that's -2. If I plug that in for x, I'm -1 from that. Isn't that a problem? I get -3, can't take the ln of -3.7. So that is not a solution, but 1.7 is the only solution. Have a great day. You should be able to answer the rest of those questions on yesterday's assignment then.